Okay, here we are, Javi. We are
Hey
live.
Theo, how are you?
I'm all right. How are you?
Good. Back to Spain after Monday.
Yeah, so we missed each other, but you were
Yeah.
where were you? Where were you? What were you doing?
So I went to Berlin for Buzzwords, which is wow, it's an amazing event. I hadn't been there before and I loved it. We were there giving a talk. It was a
Nice.
workshop actually around streaming and how to work with real-time data. It was quite nice. And yeah, now back to Spain, back home.
Nice. Yeah. Actually, I came across the conference. I think I knew about it at a previous job, and when I joined Quix a couple of months ago, I saw that they were doing it again in person and thought, hey, that could be a good one for you and Thomas to speak at. And
Yeah, it is.
I'm glad it worked out.
Mm-hmm.
But it's a long way for you.
No, well, I think it's a 3-hour flight or something like that. So
Yeah.
it's okay. Yeah.
Fair enough. Okay, cool. So let's jump into today then. So we're not going to do any kind of proper hands-on coding like we normally might, but we're going to do something slightly different, and hopefully it's going to be really interesting for people out there that are interested in stream processing. Maybe you're a data scientist or a data engineer, and maybe you want to kind of do a first project and you want to kind of get your teeth into this stuff. So yeah, let's get into it. So Javi, you're our kind of data scientist, our senior data scientist here at Quix, but you're also a lecturer and teacher, right? So tell us a bit about that. Tell us a bit about the school that you're in and typically what these students do.
Yes, definitely. So for the last 2 years, I've been teaching part-time in a digital business school called the Valley. It's an international one based mainly in Spain, but also in South America. Yeah, I've been teaching there for some years now in their masters in data science and big data analytics. It's quite cool teaching, at least in my opinion. And you do learn a lot. It is overall an amazing experience. So yeah, I've been teaching there. As part of the masters I just mentioned, well, at first they learn the data fundamentals, machine learning fundamentals, then they go on machine learning, getting to know more and more complicated algorithms and trying more. And at the end of the program, they have a project. This is what we are going to be talking about today, the project that some of these students did for their masters.
Okay, so they're doing their masters, they're learning all these different types of things around kind of data processing and all this stuff, and then they have this project at the end. And
exactly.
So from my understanding is there's a project that you are basically introduced into this school around kind of algorithmic trading predictions, and you've been using Quix as a platform for that, but fundamentally it's a slightly different project that they might do normally. Is that correct? Like, tell us a bit about...
But more than the use case, more than the algorithmic trading itself, what I wanted to introduce to the students at this school was the ability to do a project from start to finish. So traditionally in an academic environment, students will learn how to code, how to create variables, how to train models, how to validate them, but it will pretty much end up there in most cases. It will pretty much end up sharing some findings or doing a presentation on the model they've trained. What I wanted to do here with them is that they not only did that, but also put those models into production. Because in real life, in a real professional environment, a model doesn't have any value unless it is put into production, unless it is deployed. That's what I wanted them to do. And Quix was great. Quix was great for that. With the microservices approach we enable in Quix, it was a super easy tool for them to use. And not only that, but Quix is also about streaming, of course. And for this use case, I wanted them to work with real-time data, and I wanted them to react to prices, to price changes in real time. So Quix was perfect, both for the students to do the end-to-end of a data science project, and also to work with real-life data, with real-time data, sorry, based on the streaming architecture that Quix enables that.
Yeah, it makes sense. I think this is something that one of our founders spoke about a couple of weeks ago, actually, on this kind of coding in public around so many kind of data science projects actually just like get put to one side. They end up not actually being in production, and they don't end up actually being of use to the business. And that's a kind of a cliche that you've seen in real life, right?
No, yeah, that's totally the case here. You're totally right. There are these famous statistics around it. I think it was from VentureBeat or some institution like that published a year or two ago that around 9 in 10 data science projects never make it to production. That's really appalling, really, because as I said earlier, the value doesn't get produced unless the models or the transformations make it into production until they get deployed. So this is an issue in the professional world. Imagine if this is this difficult in the professional world, because it requires a complete different set of skills. Imagine how difficult it can be for students to do that. So they wouldn't be able to do it on their own. I would probably not be able to do it on my own, building a Kafka architecture to process the data in real time. I wouldn't probably be able to do it. So Quix was great for them. It is great for me for these use cases where you want to work with real-time data, with the streaming-based architectures, and you want that marriage between Kafka and microservices.
Yeah, that makes a lot of sense. And I think, like, as you said, like maybe a data scientist, like they don't have the skill capacity, or they don't have the right skills to handle Kafka in all these different kind of ways. But I think what's equally important to say in certain circumstances, right? Even if you do, like, is it worth your time and effort to actually build this infrastructure? Like, and I think that's kind of where Quix comes in, and especially in this project that you have for your master's student, there's obviously a constraint on time as well, right? So it kind of, in theory, it gives you a head start, but
it's just easier. It's just easier here. So even if you could do it, why taking the extra effort? Why, when you could be spending that extra time doing twice the impact? Yeah, it's just easier. So at least for me as a data scientist, a tool like this gives me wings to be able to be autosufficient and do the data engineering, the data science, the machine learning ops, everything I can do it on my own, and that's really good.
Cool. Yeah. All right. Well, so we set the scene a little bit. Like, let's get into actually like what the students managed to do, and maybe you could speak a bit about what their solution actually was, and like what did they learn? What did they come out with?
Sure. I think I mentioned briefly that the project was around algotrading. More specifically, this is what they had in mind. This was their abstract, what they tried. So based on crypto data, on price data from different crypto assets, they will try to develop and test a logic that will really buy and sell. So they were trying to create this bot that will buy and sell crypto assets. They wouldn't just validate it with history data, but once they had created their desired strategy, they will deploy it. The other condition is, because of academic purposes, they have to include a machine learning model in there, which at the end they all find very useful anyway. So that's what they were trying to build, a set of transformations followed by a machine learning model prediction with some other strategy tweaks that they will train and validate with historic data, and then they will deploy in real time. So that when every time the prices get updated, and this was some in the seconds, so it will be every 1 or 5 seconds, something like that. Every time they get the new prices, they will react to that, and their bot will decide whether to sell or buy, and which crypto they will sell or buy. Yeah,
makes sense. How come you use how come you use crypto as the example? Just because there's so much data and I guess it's just so volatile, right?
Yeah, crypto was nice here. They also consider traditional stocks, but crypto was nice because it was easier to get real-time data for crypto. Also, it's not like the stock market that closes at night. This is a master for professionals, so they normally have the classes or have the time to develop their projects after working hours. So it was very, very handy that cryptos are on all the time, in the evening, at night, and over the weekends. That was one of the reasons. The volatility in cryptos was the other. So they wanted to test this sort of high frequency strategy. Well, with high frequency, we are talking here again about windows of some seconds. For that, well, having some volatility will be good if their strategy is good enough. Overall, as a teacher, the objective wasn't that they will create some winning strategy to make money. Of course, it wasn't that. The objective here was that they learned about streaming and Quix. They learned about APIs. They learned about the domain they were modeling, in this case, crypto trading. So they learn about traditional trading indicators, about how cryptos work. And in terms of their mathematical transformations and algorithms, they learned about traditional algotrading strategies, how to construct variables with time series data. So it was an overall very broad learning experience for them, both in the mathematical side of things and the IT infrastructure. And yeah, as I said, the project took around 4 or 5 weeks. And we could divide it in 3 or 4 different steps. The first one was the ingestion of the data, right? So they first developed a system that will ingest price data in real time. And for that, they use Quix. As we said earlier, Quix is a nice marriage between microservices and streaming architectures, in this case, Kafka topics. So you can see that square over there represents a microservice, and that arrow over there represents a Kafka topic. We could show this another day in detail with the code and everything, but this is the basics. We have some piece of code here in this microservice that is talking to Messari in this case. This is the API.
Right. So this is the API. Is that correct? Yeah.
Yes. Okay. So they will be making a request every, remember it was 1 or 5 seconds or something like that. So every 1 to 5 seconds, they will ask, what's the price now? What's the price now for Bitcoin, for Ethereum, for Cardano, and so on, for the 10 most important cryptos? Messari will give that information back, and they will push those prices. Actually, it wasn't just prices, but also volume of trading. They will send both the prices and volume to this topic. This is a Kafka topic and a streaming infrastructure. So we can work with data coming here in real time. That's the beauty of streaming. As soon as a piece of data is generated, you can process it, as opposed to the traditional batch approach. right?
Right.
So
Yeah, okay. So in a traditional batch approach, this would go to a database, and then after the data has got there, then you analyze it. Whereas in streaming,
yes,
these things are just happening in real time. You can act on the data straight away and therefore make quicker decisions.
We have a way to show this that we use quite often. Can I use any of these slides from other presentations? Basically, in streaming, there is a good comparison that we normally make. So think of data flowing as that river that you see over there. In our crypto use case, this is price data. So as soon as the price of Bitcoin changes, for instance, we get a new point of data, and that's our flow in this river over here. With the traditional batch approach, we first store the data somewhere in between. We collect some data over time, and then periodically we throw that data in our processing, in our analytics system. So we will put in someone intermediate and then throw it into our data lake, for instance. And this is fine. It is good in some sense because we accumulate historic data over here so that we can train models, we can test different strategies for future variables creation. We can do anything that requires historic data in here.
Mm-hmm.
The disadvantage, though, is that the data that it is in here is not up to date, of course. The latest data is over here. It takes some time for that data to get to the processing system. First, we have to fill that bucket and then throw it there. So we insert some time delay, and not just that, but we insert some computational resources cost that we wouldn't have otherwise with this intermediate step. In streaming architectures, the signal will be building a pipe between our data flow and the output of the processing. And in this case, as soon as we get a new piece of data, like the new price for Bitcoin, it will be here available for us to do any processing. And I'll show you in a minute which type of processing the students build. Is that clear?
That makes sense. Yeah. So, I mean, Kirsten, so a colleague of ours, Kirsten, who's head of technical content here, she's always looking for stream processing metaphors that aren't to do with water, because that seems to be the easiest. So if you have a beautiful metaphor for stream processing, listener, please drop it in the comments or something. We'd love to hear it.
Mm-hmm. Exactly. The water one works, but yeah, it would be nice to have another one. So
we can only hope.
Yeah, and yeah, they did that here. They created that flow of water, in this case, price and volume data, that is again flowing through that Kafka topic, right? However, in Quix, you are able to also have databases. So for an streaming architecture, I will think of 3 different puzzle pieces that we need, right? One is the Kafka topics. This will be our pipes where our data will move in real time. Then we need databases. That is the containers where we store our water when we want it to be static and check it. And then we have our microservices projects. This is code living in the cloud, self-sufficient with all the libraries that it needs. And this does modifications on the data. So this will be like, yeah, the ingredients we add to our water to end up with something like Coke, if that makes sense, right?
Right, yeah.
So again, microservices where we have our code, Kafka topics where the code flows, and this is an amazingly strong and robust and fast infrastructure. And finally, databases, or when we want to store it. Well, in Quix, it is very simple to to store the data that is going through a topic in a database, if that's what you want, for the cases where you want. And they did that here. It's literally selecting persistence on or off on a topic, and that will store it or not. So they did enable persistence here because they wanted to keep a historic set of data of the prices. So their first step was to get some data on prices in real time, but not just in real time, they will also store that. And as they had 2 or 3 days of price data, they started with the next step. And the next step was to create a whole strategy on buying and selling. And this is realistic for any other project. You set up the ingestion system, you store the raw data, and then you test different value-adding processes. Like they here created some variables, some feature variables. I'll tell you a bit about that in a second. They did train a model and they put all that together in a strategy function. With the variable creation, what they were doing here is using traditional indicators for trading. So from very simple things like moving averages to more complex indicators. They use different Python libraries for that. Well, they just did like in any other project. They tested many different transformations to try to get information out of the raw data. And then with those new variables as features, they trained a machine learning model. And they did 1 or 2 strategies here with some binary classifications, some regressions. But I think both teams, by the way, there were 2 teams of students doing this independently, separately, and with different, creating different variables, training different models. So it was also quite a good thing in terms of competition. And yeah, it was quite fun. But my point was that both teams, I think, ended up going for a binary strategy where they will create a target that will be positive when certain threshold was passed, like price goes above over 0.5% or something like that. And that will be 1 when it happens and 0 when it doesn't. And with that target, they will train a binary classification model using feature variables, all the variables they had created in there. And then that model was part of a strategy. The strategy will be something like, if we don't have our money invested right now, do we want to buy? They will assess the current prices. They will predict with their models, and based on the score and based on the score label and score number, they will decide whether they wanted to enter the market or not. Then consider they are inside the market. They have bought a specific crypto. The next time the prices update, they will check whether that is going the way they want it. So that way they will be able to add both stop losses up and down. And finally, once they solve, they will have again the machine learning model for the strategy on to whether to buy again or not. So the model training was one of the bits within the strategy function that they defined. All this logic, they did it with historic data. That's how machine learning is done. That's how most of these things are done. You have as big of a batch of data as you can, and you use that for your validation, for your training and for your validation. In these cases, you save some of the data for the validation, and you train with the rest, and then you validate your hypothesis and your models with the test data that the models haven't seen yet.
Yeah, that makes sense. Because I sometimes feel there's this sense of kind of streaming versus batch. But what you're kind of saying here is that in this moment where you're kind of training an ML model and building this strategy, the only way to do it with the historical data is through batch, and that logic and strategy then gets pushed back into the stream processing pipeline. Yeah. Okay.
That's totally right here. So for this part of the process, you are going to need batch, but for the productionization, if that's a word, sorry, for the deployment of this code, you actually are going to want streaming because it is faster, it is more robust, it is more efficient. So yeah, there's no a better one between streaming or batch, just different use cases and different parts of the data science project process.
Yeah, makes sense.
Now, let's say that they were happy with the code they had created in here. So let's look at the variable creations first. There will be, within the same team, there will be some students creating new variables in Colab and testing them. And as soon as they were sort of sure that they wanted those variables, there will be other people putting those into production. So the way that that works is they will create a new microservice here. This microservice is listening to real-time price and volume crypto data. Just as we said earlier. As we said earlier, this is asking Messari about the prices and volume. It's sending it to this Kafka topic. And then this new microservice, this new code, is listening to that raw data on prices and volume. And it's using the logic that they develop offline with historic data. Well, it's using that same logic to generate those indicators in real time. And then it pushes that information to this output topic. So now this Kafka topic doesn't only contain the raw price and volume data, but also all the transformations that they created with all those new variables. That means that this topic has now, in real time, all the information that the models they develop needed for their predictions. Does that make sense?
Yeah, that makes sense. Yeah.
Cool. That was the next step. So those machine learning model artifacts, they will be brought into this next microservice. And as part of the code logic in there, they will have their machine learning model loaded. That meant that this microservice will listen to the price, volume, and indicators. It will generate an outcome based on the strategy, like selling or buying or holding. And that will be outputted to this final topic where we were studying the performance of each of the strategies. And I say each of the strategies because there were some benchmark strategies they developed. So apart from their best strategy, their winning strategy, they had these benchmarks to compete against. One was buying, I think it was, buying Bitcoin and holding. And there was this other benchmark, which was buying equally a tenth of each of the 10 most popular cryptos. So those two strategies will show how the market was evolving so that the comparison was fair with the strategy they were developing. Mm-hmm. And they did persist that data in there to save it for the future and be able to compare how they did. But as you can see, this is not a database center architecture. No, this should be. They are only saving data when they need it, when there is a purpose in saving it. Like here, we want the raw data to test different transformations and so on. But what will be the point of this code to be listening to that database to then generate variables to another database to then have this code with a model listening to that database, it wouldn't make any sense, both in efficiency, computational resources, speed. It will just be worse. It will be slower. It will be more expensive to have that.
Okay. Yeah, that makes sense. So kind of against maybe traditionally the database had this kind of central place within this architecture, and now it's more like if there's a purpose for it and we need to persist the data and see it and it's useful, then we can include it. But if not, it's not needed in the same way that it was.
Exactly. Just that. Exactly. And yeah, as you see here, this is an end-to-end project from getting the data. So I didn't give them any data. They had to source it from somewhere. So from getting the data in, to accumulating the historic data, to creating variables, to do the model training, to develop their strategies, to then putting all those into production, to do a comparison with a benchmark and check those comparisons real time. All those stages in a data science project, they were able to do it in 5 weeks, and that was quite a proud moment for me when I saw them delivering a system like this, natural growth in real time. It was quite a thing in the presentation. So the other professors in the jury were surprised as well. It's not common to be able to do all these steps in a project in this short period and by students. It was quite a moment.
I can imagine. Yeah.
And
super cool to see.
Are you curious to know which of the teams won?
Yes, I am. That's why I'm here.
Are you? Okay. Well, before showing you that, of course, again, the purpose of this project was not to make money or anything like that, but for students to learn about all the steps in a data science project and not focus just on the machine learning model training. So there were some licenses that we took to make this project simpler. For instance, we didn't compete for any taxes or fees that a trading system will actually incur in. Anyhow, just for the sake of simplification, yeah, we didn't have anything like that. So having said that, this image here shows the results. I'm gonna make it a bit bigger so we all can see. And this is for the day where they delivered their presentation.
So what are we looking at here? Is this the Quix interface, or what's this?
Yes, this is a screenshot from the Quix platform, where they can see the evolution of whatever data in a topic in real time. Yeah, again, we haven't gone into Quix and into the code or anything, because that will make this session much longer. But if someone is interested, I highly suggest they say in the comments or in any other way, and we'll create another of these sessions where we go through the code in detail and see what type of transformations and what type of models they put into production.
Yeah,
but yeah, this is taken from Quix, and it's showing you 4 lines. The line in blue there comes from one of the benchmarks. This is the benchmark where you are supposed to buy spend a tenth of your money in each of the 10 most important cryptos, and you hold that. So it shows the evolution of the market that day. You see, the presentation was around 7 to 8 in the evening, and this was running that day from 1 p.m. until the next morning. And quite interestingly, you can see that, yeah, that in blue is the benchmark. Then we have in green the other benchmark that will be Bitcoin price. And then in yellow, you see the performance of the team 1 strategy. And you can see they were full of hope because they started very well above the benchmark. Then they went down and they went up again. We didn't have a sample big enough to be able to tell whether their strategy was winning or not. again, that's not really the point of this project, but it was just fun to see. They did do several operations though, because remember they are making an operation in a matter of seconds if they want. So if their strategy was terrible, we will know by now. My point is we cannot know if it's slightly bad or slightly good, but definitely it wasn't terrible because they must have done hundreds of buying and selling operations over this period, and they stayed within the benchmarks, right?
Mm-hmm.
But on the other side, we see Team 2 that is starting not that well, but then they grew quite nicely and quite consistently over the benchmarks. So that was a very happy thing to see for them, seeing how their strategy was beating the market quite clearly. Again, not a big sample, but still they are making tens, if not hundreds of operations that time period. So we are starting to get certain statistical certainty at this point that they're into something. They're into something. I mean, not in. I wouldn't put my money in their strategy. Again, we didn't include taxes or fees in here, so this is not realistic. But as an academic exercise, it was something amazing to see how they were. Their bots were buying and selling in real time. And again, we are talking about students and about 5-week time frame. So it was very nice, very proud thing to see.
Yeah, it's super impressive to see what they can do in 5 weeks, to be honest. And I hope that like people that are listening are also thinking about like maybe something they could build themselves or something else. But I think with stream processing, it's so emergent right now that use cases are coming up all the time. But I think with kind of algo trading, it's definitely one that we see a lot of users and customers starting to play around with.
Exactly. I think something like this can be very, very interesting for two groups of people. One will be people that are interested in the algo trading use case. For them, reacting in real time can give them so many more opportunities for their trading strategies. And a streaming architecture gives them just that. As soon as there is an update on the prices, they can react to that in a matter of milliseconds. So it's really powerful in that sense. So for anyone out there interested in algo trading, giving a try to streaming, and I will honestly say Quix because it's the easiest way, will be something to do. And then on the other hand, even for people who are not interested at all in algo trading, the other key thing to see here is how you can create streaming architectures end-to-end quite easily. So even for a data scientist like me who doesn't have experience with Kafka, I'm able with these microservices and Kafka marriage to develop and deploy an architecture that is very robust, very performant, very, very efficient. And that's quite something. I mean, for someone like me, not to depend on data engineers or data architectures or anyone really, build a project from the beginning to the end on my own, that's really nice. It's really powerful. So again, to summarize, I would say anyone interested in algo trading, they should check streaming. And anyone interested in streaming architectures, they should check Quix because it's the self-sufficient way to do it, the easy way to do it. Just as a reminder, even when they use Kafka behind the scenes, all they use for coding was Python. So it is really simple. You can see some images of the platform there. We have so many other videos where we show the platform. It is really simple to get on and do something like this.
Yeah, super cool to see. And I think it's worth saying on the Quix thing, like obviously we have a bias view towards Quix and how you can do this stuff. And by all means, like there are other products out there. But if people did want to get started with Quix and trying to build something like this, like how do people reach out to you, Javi?
Okay. I guess the easiest way will be to sign up once, obviously it's for free. We have the free trial account for developers. So no credit card needed or anything. They sign up, and part of the resources is the live chat. So by accessing there within the platform, they can contact on Slack anyone here on our team. Part of our job is to help. So we will be glad to jump on a call and try to help them develop their projects. We also have a whole set of tutorials and documentation that will help them get on with. But yeah, they can talk to us or they can just try on themselves.
Yeah, makes sense. Yeah, by all means, reach out to us, and maybe we run another session with kind of digging into this project with code. And if that's of interest, just like leave a comment on the YouTube video, and yeah, we'll make that happen.
Exactly, and that will include the specific beatable transformations that the students created, how their trading strategies were. We will dive into the technical detail if you are interested. We'll see code by code, line by line. It will be a more in-depth, maybe longer session. But if you are interested on that, leave a comment and we'll do it.
Cool. All right. Well, I think that's it. Thanks so much, Javi, for showing us that. Like super impressive what your students have done, and look forward to doing more of these things with you in the future.
Yes.